As developers, context switching reduces our efficiency significantly and can cause frustration. How many of you would love to work in a world where you get to work in a consistent, expressive, concise, and fun programming language all day, both for app development and the tools that we compile it in? I know I would. Not everyone in the room. Come on. I'm Ty, and this is my colleague Yohan. We're Android developers at Twitter, and today we're going to walk you through a fun new language called Kotlin and how it can help make your lives better. We'll walk you through a short overview of the language and then through some real-world examples of using it within Gradle. But first, why do we need change at all? One of the major talking points these days is in Android is when we'll get Java 8. Unfortunately, if we do, based on historical data, it'll be a while. And it'll be longer still until that version of Android reaches enough adoption that we can develop explicitly for that and above. So keep in mind that to use Java 7, you would have fully, including try with resources, that you'd have to target KitKat and above, which is still less than 40% of the market. Next, Java and Android together can be quite prone to error. I wouldn't work on a crash reporting team if that wasn't the case. Capturing inner classes, for example, leaves your apps prone to memory leaks. And there are syntactical problems with Java 6, such as lambdas and streaming. We just don't have them. But there are systematic problems as well, such as the verboseness and nullability that come with the Java language, regardless of version. These syntactical problems can be solved with some great libraries that improve the app development and safely backport those features from Java 8 back, like RetroLambda and RxJava. But these systematic problems are a bit more of an issue. We believe Kotlin delivers on most of these out of the box. If you've been living under a big rock, maybe you haven't heard of Kotlin before. But it's built by the JetBrains team, the same guys behind IntelliJ and Android Studio, and it's completely open source. It's designed with mobile first in mind, with Android developers being a large target audience. And because it's designed to work 100% with Android, the bytecode generated by Kotlin is completely compatible with JVM6. The language runtime that needs to be bundled with your application binary is incredibly small, coming in at less than a megabyte. And because it's statically typed, and it follows Java's mutability model and it keeps memory allocation in mind, we don't really have the same runtime overhead that would be generated by using a dynamic or an immutable language on the JVM, such as Groovy or Scala. This is a large constraint on Android, by the way. Lastly, Kotlin is a modern language with many awesome features that make development fun again. So let's go through a few of these and talk about how it can help. Well, by utilizing Kotlin's type system for null safety, it can help us reduce easy-to-avoid null pointer exceptions and avoid nasty states. Kotlin gives us great ways to reduce the boilerplate code that's required from Java, making our code much more maintainable. Android APIs are generally one large inheritance party, to put it as Jake Wharton said. And although this works well for them, it puts the burden on the app developer, especially when you're focusing on an architecture of composition. There are many APIs that require a ceremony to complete properly. Just think about the steps required for toasting something, for saving in shared preferences, for SQLite transactions, or starting the media recorder. Lastly, while Java is too verbose to accurately define a build script, we believe that Kotlin is expressive and concise enough to compete with many aspects of Groovy, the preferred build scripting language of Gradle, while providing much needed type safety to reduce errors and expedite development through better IDE integration. There are a lot of Kotlin features. We have higher order functions, properties, mixins. There's a lot of these. We don't have all night, so I'll just instead go through a few that we think can work really well to show off the Gradle examples that Yohan's going to walk through in a bit. One of the most common exceptions in Java development are null pointer exceptions, infamously known as the billion-dollar mistake. Unfortunately, Java doesn't have the same first-class representation of something that may or may not be null. By having runtime-based null checks, it makes the code much more susceptible, even when the null checks are being utilized, even when you're doing it. Having a potential value of null requires defensive programming across your entire code base, which leads to a much less maintainable code base. So here's our first example that shows Kotlin's variable assignments. You'll notice that Kotlin uses a syntax where it reverses the type and the variable name for declaration. In this case, we'd get a compiler time exception, not a runtime exception on the second line, because we are not allowed to assign null to the variable a. However, in this next example, you'll note that the question mark along with the declaration. This indicates to Kotlin that the value may be null, and we'll take care of checking that. Once we try to utilize that variable, we will see a compilation as error as well, as we needed to explicitly check for null before using it. You may also note the two different ways of declaring a variable here, both var and val. Kotlin uses var to indicate a mutable variable, and it uses val to indicate an immutable value. In this last example of nullability, we can use a few different formats to check for null. In the first line of code, note the question mark in use again. When that is declared, any further method calls on that object will return null if the parent object is null. This removes the need for doing a bunch of nested if null checks. In the second line of code, we follow a slightly different format. Instead of utilizing null as the result, we specify a default value using a single expression if else. Finally, in the last one on the page, we take advantage of the Elvis operator to simplify the syntax of that second example, doing the exact same thing. Let's move on to another cool feature of Kotlin, class properties. In this example, we'll define a class called user, and we'll specify a member variable for the name. Using the syntax where we put the member in line with the class name is one approach, although we could specify it below in the class as well. Although this looks like a standard Java field, this is a synthetic property. That means that getters and setters are automatically generated, and this is what's being used near the bottom of the slide in the setName function. We can, however, override those default generated getters and setters to specify custom logic by declaring a get and a set method below the property. You'll notice that we changed the syntax for the property for declaring it. We moved it down into the class for better readability. In addition to using properties to clean up boilerplate code, Kotlin offers another concept as well called the data class. You'll note the data keyword. This is designed to be a lightweight POJO and do all of those things that in the classes normally need. By adding the data keyword, we get things like automatically generating equals and hashcode method. We also automatically get a toString generated with all of the constructor parameters in this format. And it'll generate the copy method with default parameters, so that you don't have to implement builders to copy and create immutable POJOs across your code base. Data classes have many limits, though. For example, they cannot extend another class or be abstract. I'd recommend looking up the restrictions to see if it's right for you. Let's move on to another example. Function literals, or lambdas, are a great way to make code more readable and have come to be expected from other modern languages. Java 6 doesn't have support for these, but using a framework like RetroLambda that rewrites bytecode from lambdas to single abstract methods is a great way to get it in pure Java 6 if you can't use Kotlin today. Lucky for us, though, we get it out of the box with Kotlin. In this example, we see a few different syntactical ways to declare them. They will infer their type directly from the definition, so we can reference the variables directly in this first example. In the second, we only have a single parameter, so we can refer to it with the standard it notation, similar to Groovy or Java 8 or many other languages. Expanding on the function literal concept, Kotlin also provides us with higher order functions, or functions that take functions as parameters or return functions. This is a powerful technique to write clean and readable code. And we'll get to see some more powerful examples of this for real-world Android use cases coming up. But we need to understand one more concept before we get into that. This last concept I want to talk about is called extension functions. Kotlin gives you the ability to add methods to existing types. Think about that. It's very powerful, and it's similar to other languages like C#. This is a great way to replace the utility hell that Java becomes, where you have a util class representing interactions with an object that's out of your control. This syntax requires that you just define the type.method name, and then the code interacts with that class as if it was owned by that class. Please note that you can't really override existing methods using this. Another thing to note is that Kotlin only gives you the method in a class where you've defined the function extension. So if you wanted to use it in a separate class, you would have to explicitly import it. Also, since this is 100% compatible with JVM6 bytecode, maybe you're saying what's going on here, this is generating static methods under the hood as well. So if you compared it to just the bytecode of writing a static method, it's going to look the same. This can be really powerful in Android. Here's the traditional way of saving an object into shared preferences. You can see that it requires us to init the preference editor, put the object, and then call apply. This is prone for errors, as it requires specific ceremony to be followed exactly. How can we make this better? Here's the Kotlin version. It's the exact same functionality as the last slide, but using the three concepts we talked about, extension functions, higher order functions, and function literals, we can add a method to the existing shared preference object that takes a function literal that is defined as another extension function of the editor class. Now, this can be quite confusing at first, but it's incredibly powerful. It allows any function literal passed in to behave as if it was a method on the object here, on the shared preference editor object. This allows us to use code in a type-safe way, knowing that when a string is saved, without having to worry about referencing the correct editor object, with it or with something that you've declared outside of the scope. A caveat to note, though, is that since Kotlin is Java 6 compatible, using higher order functions imposes certain runtime penalties. Each function is an object, and it captures a closure. Those variables that are accessed in the body of the function. So now we have memory allocations, both for the function objects as well as the classes, and virtual calls that introduce runtime overhead. By adding the inline keyword to the function declaration, we're telling the Kotlin compiler to compile the code in line with the Java, as if we had written it in the very first Java version that I showed you, which, while error-prone for developer maintenance, is the most machine-friendly. Now our bytecode between Kotlin and Java is identical. Remember when I said that Kotlin doesn't add runtime overhead? This is one of those features that allows that. These Kotlin features give us a powerful ability to create a DSL. There's a cool library called Anko, written by the JetBrains team, that allows you to cleanly describe Android layouts without using XML. Hopefully, you can start to see how the use of function literals, extension functions, and higher order functions can produce something like this. You may also start to notice the syntax is starting to look alarmingly similar to Groovy. So maybe by now I've sold you on using Kotlin in your Android app. But introducing that would further add fragmentation to your code base. You may have Kotlin in your app, a mix of Groovy and Java in your Gradle build script and your plugins. That's 3 languages to think about. Humans aren't great at context switching. That overhead is going to reduce developer productivity on your team. Maybe we can take Kotlin to the next level by using it in the build tool as well. I'm going to hand it over to Yohan so he can explore that.
Thank you, Ty. So we've seen a lot of the cool features of Kotlin, and what I'll do now is walk through some real-world example where you extend Gradle and build your own plugins and things like that, and how you could also do that in Groovy. So this is a common scenario that a lot of Android engineers would be familiar with, using the API keys to connect to the web service. So let's focus on the API key specifically. One obvious improvement that we can do here is to separate out the different API keys for different build types and flavors. So what's more interesting problem? What if you want to push your code to open source and you want to separate out your production key? So ideally, we have a separation of concerns and have this key provided to the application. So this is where Gradle really shines as a build tooling, how it integrates between the build and the application itself. What we have here is an Android Gradle plugin DSL that allows us to add constant to the generated build config class. The syntax is very straightforward. And here's what the generated code looks like. As you can see, the second line, you can just refer to the constant that will be generated by Gradle during the build time. But that's not enough. You still have your code, you still have your production keys in the build.gradle, and you want that to be provided externally. So Gradle provides a number of ways. One common way is the Gradle properties, or the project properties, sometimes people refer to it. You can pass to your build tooling by passing -p parameter, or the other one is the system variables, or the -d. So if you use CI like Jenkins or TeamCity, they have a very great integration on how you can configure system variables. And lastly, you can always load your own properties file within build.gradles and use that for the rest of your build lifecycle. In practice, the choice varies, and every team have their own policy, they have their own structure, it's largely driven by that and also what your CI of choice is. So here's an example of how you can provide the value in the build.gradle. You can write a function that use both Gradle properties and system variables and then set the order of the precedence. So what you have now is your development environment. You can have your developer key. And when it comes to CI build, the system variable will always take precedent and override that. So the build engineers and DevOps love this because it will override any accidental check-ins of development keys. And within your build.gradle, you can just use the string extrapolation and calling that function that you just created. Now, you are in a position where you have multiple keys, and it's really tedious to maintain all that when you have different CIs, when you have new engineers coming in. So what you want to do now is abstract that further, creating like a custom properties file where you put your keys there and a list of all the keys that you need. And to simplify onboarding new engineers or when you're setting up a new CI machine, what would be good is if you can create a task that creates this file. So that's where you now start dealing with custom tasks. So this is an example where you write a custom task in your build.gradle. So this is a Groovy script. And if you're a Java engineer and you're not very familiar with Groovy, this function will be of interest to you, the with.output stream. It wraps the creation of the output streams, and it also reading out the output stream and hand it over to the properties object. So you can see the it parameter there. That's very similar to Kotlin as well. And like Kotlin, Groovy also doesn't have a concept of check exceptions. So you don't have to deal with file not found or IO exceptions and etc. So making the code really concise. So now all you need to do is run the task once whenever you have new environment or when you have new keys that you need to set up. You add custom properties to your git ignore, and you can push your code to GitHub, and you have your key separate out from your code. Now, the situation is you have more than one app in your team, or you want to share the same process to other apps or other teams that you work on. So you want to create a plugin to share. So the three basic ingredients of Gradle plugins, the usual is a task that represents an action that you can trigger from the command line or another task, as we've seen before. The other one is the extensions that allows you to configure what that task is running or the different inputs that that task requires. And lastly, the plugin itself that you can use to bind all these components into the Gradle lifecycle. So very quickly now, if we were to take out that function that we had put in the build.gradle, we separate out, we create a separate task called create properties file task, extending from default task. And all you need to do to write a task is annotate a function with task actions, and that will be executed when the task is triggered. So again, you can see the code is very concise. So let's compare that if we had written the same task in Java. So you can see now the code's starting to get really big. You have the null check, you have the catch exceptions, the error handling, and etc. And for dramatic effect, I'll show you what it looks like if you had commented out all the ceremonial codes. So that's pretty much just about the same as the Groovy version that we saw earlier. So another important part of the task is you have the inputs and the outputs. You have annotation input to denote that a field is a task input, and an output file. Here is an example of a spatial output annotations to denote that this field, this task have an output in the form of file, and Gradle will use this kind of information when it comes to incremental build and clean tasks. Okay, so the other part of the Gradle plugin that we want to build is the an extension. So in this case, we have 3 different data members, and this is called Pogo in the Groovy version of Pogo. And again, it's very similar to Kotlin. Groovy will add the getter and setter at compile time. So you have get keys automatically by writing this. And to make it more idiomatic, when we configure the build.gradle, we provide some key file function to shortcut the assignment. And you can also copy the get prop function that we wrote earlier in the build.gradle. You put it in your extension, and anyone who applies your plugin can have access to that function. So very standard. And now we're getting into the plugin. So this is where we bind all the stuff that we just built. We create new extensions, and typically, when you're dealing with plugin, there's a lot of interaction with the project object. You want to add tasks, you want to add extensions, etc. So Gradle provides configure functions, and it takes a project. You can pass in a project parameter there, and within the closure, it now knows the context of extensions. So instead of typing project.extensions, you can just say extensions.create. Again, this is very similar to one of the features that Kotlin that Kai showed earlier. As you can see, by using that configure, the code is slightly more concise. So one other aspect that a lot of plugin developers tend to do is to use the after evaluate closure. So the reason why you want to do that is because you want to make sure, you want to give time to the consumer of your plugin to set up the key file and the keys. And what after evaluate make sure is that it will only be executed after your initialization completes. So now we have the plugin completed, and this is a very short way to use it in, you can use it in many projects. You can just apply the plugin that you just built, and as you can see, we now have this extension that's very similar to the Android DSL. You have the keys and key file and etc. So now let's see what it looks like if we write the same one in Kotlin. So starting again from the task, very important part of the plugin. So again, we have the create properties file task. We extend from default tasks, and we also have two different fields. What's interesting here is the attribute opened that's at the beginning. So that's to mark that this class is not final. And by default, all classes in Kotlin are final, which is problematic for Gradle tasks because Gradle, when they instantiate the real object for tasks, it actually inherits from the task, the class that you provide to it. So it needs the ability to extend that class. So by denoting it as open, you make sure that it's not final, and Gradle can extend that task class and do its own stuff. And here's a version of the create file function that we just saw earlier. We translated line by line, and it looks very similar to Groovy. I think there's slightly change in the for loop. It has a very slightly different syntax from like Java. But you can see it's still very concise. And again, because it doesn't have that check exceptions, you don't need to put in the different try-cats there. Any exception that's caught will uncaught exceptions will just be elevated to the caller of the function. So here is another version of writing the same one in Kotlin that's probably more idiomatic or concise. So gone is the for loop. We replace it with a function literal, or sometimes we call it lambda. And what's even more interesting here is the last line. So we have the double bang operator. So remember how key file was nullable? So I'll just show you quickly. Sorry about that. So we made key file here nullable. We don't have to make it nullable, but I made it nullable to show this one feature of Kotlin. So Ty mentioned different ways to handle the nullability, but it is another way. Like you're stuck with Java classes that are pretty much nullable in the Kotlin world now. So the double bang will pretty much just do that null check for you and throw NPE if the key file turned out to be null at that point of the code. And here's the version of the extension class. So we're using the data class feature that Ty was talking about. And what's interesting here is that it's even more concise than the Groovy version that we saw earlier. So this class has one constructor that takes 3 different parameters. And again, we make custom file nullable just for the sake of it. Yeah, and it will extend all, it will create all the getter and setter for you, like the Groovy version. So moving to the plugin class now, similar to what we did earlier, we want to add extension to the project. And this version, we use the add, not the create, because we want to instantiate it ourselves. So again, we also want to use the after evaluate closure to allow the values populated by the consumer in the build.gradle. At this stage, the code looks very verbose, and we want to improve that. So remember the extension functions that Ty mentioned earlier? So here's how we can utilize it to make the code in the previous slide even more concise. So we create 3 different extension functions. One is the project.configure, and all it does is execute whatever the higher order level function that you pass to it. And then the second one is similar to that. And the third one's probably slightly interesting. You have the casting there because get by name just return object. So we cast it, we make sure that it always return a property holder extensions. By adding these 3 extension functions, suddenly we now have a lot more concise code. So we have project.configure. Configure is that extension function that we just created. The extension itself is also another extension function that we just created earlier. And here's the final version of our plugin in Kotlin. So it's very declarative, it's very concise, and if you use Anko in your Android application tool, all your codes will be like this: declarative, concise, less error-proof, and kind of reminds you of the build.gradle. So I hope we convince you now that there's a lot of values in looking at Kotlin, both on the Android side and how you can use it on the Gradle side. We've also experimented with the new models API that Hans mentioned. We run it, and it's pretty successful so far in our limited use cases. And yeah, so you get excited, and here's some more great resources to help you if you want to learn more about Kotlin. The first one is the official docs. They are great learning resources with a lot of information. And Kotlin Koans, which is the tutorial side of Kotlin, and they also have the GitHub open source project that you can just download and play around on offline. And Anko, again, is the Android library that Ty mentioned, how you can write a layout in Kotlin without XML. And Jake Warden gave a talk earlier this year, dive deep into how to use Kotlin in the Android side specifically. Okay.
Thanks for your time, everyone. The more people, the more of us that use and contribute to Kotlin, the faster we can all have a modern language in our day jobs. Since Google may take a while to officially sanction Kotlin, if they ever do, it's up to us in the community to drive best practices forward. While Google owns Android, it's an open source ecosystem, and we are all responsible for making it better. All right, we're open to questions for, I guess, a couple minutes now. Are we using Kotlin in any current production apps? And I'll say that we are exploring Kotlin's use in production apps, but there's nothing that's shipped with it right now. Yes?
The question is, can you use any Gradle API? And the answer is, most of the Gradle APIs are written in Java. So I think the confusing part's probably the closure part. And most of it is actually just actioned. And the Gradle at runtime convert that, at compile time, adds the version of the closure. But if you look at the API, if you look at the source code of Gradle APIs, they're all just Java that takes action. So you can use Lambda for that. And you can interact with the Java classes too.
So the closure in Groovy, in Gradle specifically, is in most places are generated at build time. The API actually declares an action, which is a single abstract method. That way, if you were using any language that could convert a Lambda into a single abstract method, Java 8, JRuby closure, whatever, that would all work. So Kotlin would interact with that. If you wanted to interact with the closure implementation, then you would need to write your own binding. But because you have the action and it's the same API, it'll just use that.
Yeah, you could also do that. Like closure essentially just an abstract class, and all the calls will be delegated to a doCall method. So you can create an anonymous inner class that overrides doCall method. Yeah.
Hi. Do you have your tests written in Kotlin or only production code, only application code written in Kotlin?
I think the question was, are we using Kotlin in our testing code for production? Right now, Kotlin is a newer language for us, so we've been exploring it both in...
Not for production, but for you exploring Kotlin.
Yes.
And have you tried it in testing? And does it add some value for the testing perspective?
Sure, absolutely. Kotlin is great for testing because it allows you to use those extension methods to possibly access stuff that you wouldn't otherwise want to happen. And it doesn't add any overhead to your production code. So if you're on the fence about using Kotlin in your app, adding it in your as a test dependency is a great way to get started with it and make your tests easier to use and see how that feels and then kind of move it into production over time. Perfect. So I think that Kotlin itself is, what are the obstacles to get Kotlin into production, was the question. And I think that one is the Kotlin language is still evolving, so there might be minor API changes. Even though they are in beta now, we expect very few. There's a potential. So depending on the size of your company, the size of your team, that's a sell that you have to make to say, hey, we're going to include this language. There's a runtime. It may possibly change in the future. Is that a problem? So that's probably a big one. Another one, if you're not in a product team, if you're a consultant or a contractor, then it's probably going to be a little more difficult to convince a client to use this brand new thing. And that's why I'm hoping before long, Google will come out with at least something acknowledging that it exists. That way it's a little easier to say, hey, client, like instead of using this very old legacy language, we can do something a little more modern with all the benefits that we talked about. But right now, I think both of those are a bit of a concern. Yep. Maybe I should rephrase my answer. It would be nice if they had it in the official docs somewhere that it's at least somewhat compatible. That way, when a client goes and does a Google search for it, it pops up and it's not nested down in some talk from some random Google engineer.
I think if I'm not mistaken, is the data binding component was written in Kotlin as the main language.
Yep, that's true. So there's a couple steps to get it running. You add the runtime dependency, which is the language, the standard library, and you add a compile time dependency to your Gradle script. And then you just create a Kotlin file in Android Studio. You install the plugin for Kotlin in Android Studio or IntelliJ as well. Since it's written by JetBrains, you would expect it has pretty nice IntelliJ integration. That actually brings up a really good point. You asked about challenges. The autocomplete and all the docs and everything else for using an IntelliJ or Android Studio aren't as great with Kotlin as they are with Java. So using quick fix and things like that, if you're accustomed to that, that's very rarely going to give you valuable stuff in Kotlin, but as it does in Java most of the time.
I think one thing to mention, Ty, the counter side of it is Kotlin has a REPL side on IntelliJ. So if you're familiar with other language that has REPL and you like it, Kotlin provides that too if you want to experiment with the language. Another question.
Hey, what have you been taking advantage of the most within Kotlin that you can't really get in Java 6.5 with Retro Lambda and all that?
Sure. So I think that the features I kind of called out in the beginning were the ones that excited me the most and that I run into the most. So nullability is a great one, having much lighter weight, POJOs and not using the accessors. And then specifically the function literals being used and passed in as extension functions on higher order functions. Like that's the more complex piece where you mapped it all together, but it allows you to do incredible things to the Android API. Like I showed the example with shared pref, but you can also do that with, with a SQL transactions. Jake Wharton shows an example of that in his talk, where you need to begin your transaction, write your stuff, close it, do a try finally, catch on it all, and by creating one function literal that manages all of that for you and just takes in the logic, it allows you to very easily clean up the Android API and kind of remove a lot of that ceremony. And I found that it's great for kind of scaling. That is probably one of the highest potentials for interacting with Android.
Okay, I guess we have to cut it. You guys, if you have any more questions, you can catch Ty and Yohan out there. Give it up for Ty and Yohan. Thanks for telling us about Kotlin.